Hello everyone, I'm Manogna Srinivas. I'll be presenting our work, Similar Class Style Augmentation for Efficient Cross-Domain Few-Shot Learning. So in this problem, during training stage, one has access to multiple source domains which are all labeled. These domains are used to learn a universal feature extractor that learns generic image representations. Given this model, the objective during testing is to adapt to novel tasks coming from unseen domains. A few-shot task is characterized by a support set that consists of a handful of labeled training samples, using which we adapt the universal feature extractor. This model is then evaluated over the query set. So we evaluate our framework on the metadata set benchmark, which consists of 8 training domains and 5 unseen test domains from which n-way k-shot tasks are sampled. Similar to several prior few-shot task adaptation methods, we also employ a nearest centroid classifier where the class centroid is computed as the mean feature representation of the support set samples that belong to a particular class. Then the nearest centroid classification loss is employed to update the batch normalization parameters gamma and beta, which actually constitute only a small portion of the network parameters. As we operate in the low data regime, so it is natural to consider doing augmentations like scale and feature augmentations like iMix or mix style. We propose a novel similar class style augmentation, which is inspired from mixed style that was proposed for domain generalization task. Firstly, we compute the cosine similarity of each pair of classes. And then for each class, we identify the similar classes based on a threshold on the cosine similarity. Then we use the style statistics from similar class samples to augment our support set. Suppose we have an image from cat class in our task. Dog is a similar class to cat. Then we use the style of dog to augment the cat image. The feature statistics of early layers in the network capture the style information of an image. The mu's and sigmas of the features represent its corresponding style statistics. These can be used to obtain an intermediate style statistic mu mix and sigma mix, which is then used to renormalize the feature to get the style augmented feature. Now, along with the original features, we also have the style augmented features, which are used to optimize the nearest centroid classification loss. The batch normalization parameters in the network are updated, keeping the conv layers fixed for efficient learning. This proposed SSA-BNS framework is observed to consistently perform at par with the state-of-the-art method and TSA, and can also be incorporated as an additional module to existing frameworks, and it consistently improves the performance in both seen domains as well as unseen domains. Thank you, everyone.